Hello everyone, I'm Jay, your host at Everything Cloud Platform. Welcome to this session on creating and connecting a GKE cluster. We'll go ahead with creating a GKE auto cluster. We'll go through all the configuration parameters that go into building or creating a GKE cluster. We'll get into a little bit. We'll touch upon all the configuration parameters like networking, the IP ranges, etc., that are important for you to understand how GKE clusters work. And then we'll go about connecting to this cluster both from your laptop as well as, say, from a VM running in the authorized network. So let's dive right in. Navigate to Kubernetes from here. Navigate to clusters. Now we are getting ready to start creating our cluster. If I say create here, let's see all the fields. Now we'll go over all of these steps to create an autopilot cluster, and we are creating from GCP console. In other sessions we will talk about how we create the cluster using, say, gcloud or IAC / Terraform. So first we'll name our cluster, or we'll just call it SRE. We have always been using US East 1. I'll stick with US East 1. Next is our networking settings. So if I click networking, now there is a lot of information in here for which I'll need to just enable you on a little bit on IP addresses and CIDR ranges. So there are some, just know that there are some private IP addresses that are called RFC 1918 range. If you navigate to the subnets page, and this is a Google Cloud documentation page, when I say a private IPv4 address range, this is what we are referring to. If somebody says RFC 1918, they are referring to these IP address ranges. Just note all of these very clearly in your mind. 10.0.0.0/8, 172.16.0.0/12, 192.168.0.0.16. You will need to know these. Now, what does this /8 really means? This is called a CIDR notation, CIDR. So what does this expand to? There are some tools out there available on the internet that you can use. So let's use this tool right here to see what this one of these ranges really means. If I just copy this 192.168.0.0, that's what you're seeing here, and if I say /16, that's what that page was saying. So this range really translates to all the IP addresses between this 192.168.0.0 till 192.168.255.255. That's the range of IP addresses, and that's a total of 65,536 IP addresses that you get in this subnet of this CIDR notation. That's what it means. To summarize, the point being, you represent a range of IPs using a CIDR range. Now, that's just a high level on IP addresses, and that's important to understand because we'll use some of these ranges as we are creating the cluster. But there is a lot more to IP addresses and subnetting, and we'll do a separate session on getting into details. A quick cheat sheet of how many IP addresses do you get within a CIDR range. This quick subnetting chart gives you this. For example, if I'm saying if I'm providing you this range /15 gives you 131k IP addresses, /16 gives you 65k. So you'll need to know some of this. Back to creating the cluster. So on networking, I'll select the default. Let's select the default network. Now, some of this networking, as you mature and build production systems in network, typically you will have a shared VPC sitting in a different host project, and your service projects will be is where you will be working, and so on and so forth. So just keep that complication out for now. For this demo, we are keeping things simple. Everything is within the default network, and within the default network, we'll select the default subnet. Now, IPv4 network address. choose the network type of network we want. Now, public cluster, it's never a good practice to have a public to go with a public cluster. And that's one of the important security aspects that you would want to consider. We would want to have the private cluster and assign internal IP addresses to pods and nodes. So I'll select private cluster here. Now, if I am choosing private cluster, then we'll need to configure Cloud NAT, and this we did in one of the earlier sessions already, as we got rid of our external IPs from our VMs. So you could refer to the other relevant videos from the series of videos available in one of the earlier sessions. But Cloud NAT, basically this enables your services within GCP to access internet via this, and hence you do not really need to assign specific external IP addresses to each of your resources. That's the Cloud NAT that we are talking about. So if I go back, we already have this in place, so we'll go ahead. Now this one is saying access control plane using its external IP addresses. So disabling this locks down, but we want to be able to use this, so we'll keep this open and we'll have a control plane IP range. Now this is asking for control plane IP range, this is asking for pod address range, service address range. You will need to have all of this handy, and there is one IP address range that we will need to assign for this control plane authorized network as well. So we'll start assigning some of these, and you will need to know that these cannot overlap. The IP addresses cannot overlap, and I'll show you what kind of errors will you run into if you have your IP addresses overlapping. So what I'll do is, for pods, I'm saying I'll go with this, which means this 10.125.0.0/16 will give me a total of 64k IP addresses, right? /16, if you look at from here, that gives you a total of 65k IP addresses. Now, say if I provide the same range here, there is a problem, right? Because it won't let you have your IP addresses overlap. So what we'll do is we'll use, say, 10.126 and we'll say /17, and that /17 is a smaller range. /17 will give me a total of 32k. We can go smaller as well, but it depends on your need. Now, when you actually design some of the subnetting for your production systems, currently I have the flexibility here in this demo session to be generous with all the IP addresses that I'm using, but in reality, in production systems, you will be struggling to ensure you're using the IP address space right. So there is a lot more that will go into the subnetting exercise, and that's for another day. But yeah, this is how you choose your IP CIDR ranges. For control plane as well, let's provide an internal RFC 1918 range, and we'll keep this a little different. We'll say 172.16. Keep in mind we have these three options, right? So we are using this one for pods and services, this one for control plane, and we'll use 192.168 for our authorized network. And let's get there now. After we provided this, let's see what this is saying. Enable control plane global access. With the global access, you can access the control plane's private endpoint from any GCP region or on-prem, no matter what cluster's region is. So we are not, maybe let's go ahead and enable that, because we want to be able to access it from our laptop from outside. Enable control plane authorized network. Now notice the tooltip there. Enable control plane authorized networks to block untrusted non-GCP source IPs from accessing the Kubernetes control plane through HTTPS. And this says enabling control plane authorized networks is strongly recommended for private clusters. So we should, right? And this is what it says. If you plan to access your cluster using kubectl from outside GCP, you must add at least one authorized network, and we'll go ahead and add the authorized network here. So we will say just say code garage here. All right, and the CIDR notation we'll provide, say 192.16 here. right? So that's our CIDR notation. So we are saying these 16 IPs in this CIDR range is what our new authorized network is. So just keep in mind, 172.16 is for control plane, 10.125 and 126 are for pods and services respectively. 192.168 is for our authorized network. We say done here, we move forward. Okay, one more thing before we move forward. We add network tags. We will use it for some or the other thing in future. So for now, I'm just adding GKE node as the network tab. Remember, for our web server, we added a tag called web hyphen server. So on similar lines, we do a GKE node here. All right. Now some advanced setting. Just leave the default here. For automation, just leave the default here. We're not doing any of that. Anthos service mesh. Now this is important. This adds some of the service mesh and Istio related capabilities that you'll be strongly needing for the service to service communication. It just simplifies all the networking within the services, and Anthos service mesh and Istio capabilities is a whole topic on its own. For now, we'll just enable this. This is important, and there's a lot more documentation around ASM, but for now we'll just go ahead and enable ASM. Security, just leave the defaults. We can enable binary authorization, Google groups for our bag. We can do all of this, but that's for future. For now, we'll just keep it simple, so we don't lock it down a lot, so that we can play around with the cluster really well. So we'll leave the defaults. Then for operations, enable logging, all of this is already enabled. Take a quick peek at all of this. I'll actually select all of them. I want all the logging to be enabled really well. Of course, this will mean that you are adding, you're going to be flooding your logging, but that's okay. We'll remove these logging as needed in future. But for now, just enable all. Here as well, I'll just say select all. I'll have more logging enabled. Metadata, see if there is any. This is my SRE cluster for demo sessions, and we'll add a couple of labels here. The standard practice that we have been following with everything, provision by is one of the labels. It says manual when we are creating anything from GCP console. It says Terraform when something is being created using IAC Terraform, and it's gcloud when you're creating the resource using gcloud commands. I will go ahead and say next. Next is my fleet. I won't change anything to this because this is ASM related setting, and I'll say review and create. Just review all the information. Your cluster name is SRE, your cluster location is US East. These are our IP ranges that we have configured, and these are some of the advanced settings that we configured. And at this point, I'm ready to go ahead and hit create cluster. Cluster creation takes a few minutes, so wait for a few minutes and you will see the cluster finally getting created. Now I'll click on SRE cluster and see what all do you get. You get the details, and I would say just spend some time, review each one of these details. Now you will notice that there are some fields that are logged here. So these are immutable fields that you cannot change as we go forward. But there are some like binary authorization. During the creation, we did not enable it. We can very well enable it as we go forward. But for now, let's just review everything that we have created. Networking, notice our CIDR ranges that we provided. We will keep referring to some of these cyber ranges as we go forward. Notice that Anthos service mesh is enabled. Take a quick peek at your storage page. Observability. Now there is a lot of out of the box observability that is already available to you. So that's these are things that you will be able to see. Look at some of the CPU, etc. Now keep in mind, this is auto cluster. You are not really managing the nodes behind it yourselves. Google does that for you in auto cluster. Whereas in the standard cluster, you manage the nodes and everything your Kubernetes is running on. But note that all of this information is available to you. Now these are logs. I will go ahead and open this in a separate window so that you can see what kind of logs are available to you and what is the appropriate filter. Notice the filter here. The resource type is K8's cluster. For the Cloud Run, for example, we were looking at Cloud Run revision. For GCE instance, this resource type was GCE underscore instance, and so on and so forth. So that's how you go about filtering out the logs for your cluster. It has the cluster name as well in your filter query. We'll see a lot more here as we start running applications on this cluster. Let's head back to the page and see if we see anything right here. We'll look at some of these in details as we start hosting some applications. Let's connect our to our cluster from our command line, because that's where we'll be playing around with the cluster a lot. So let me get to a few commands. I'll show you a few commands that you can use to connect to the cluster. So say gcloud container. This is where you have all of your commands. So if I say gcloud container help, you will see one of the groups here is clusters. So to gcloud container clusters help, you will see a lot of commands here as well. Now we will use some of the commands here, like you can use this to create a cluster. You can use this to create the autopilot cluster that we created. You can very well use the gcloud container clusters create auto command to create an auto cluster. We'll use this get credentials here right now to authenticate us against the cluster and to be able to access its resources. So we are going to do this. gcloud container clusters get credentials. Our region was US East. I'll say SRE was our name, right? Now it created. Now that you are connected to your cluster, let's try and see if we are able to run our kubectl commands. Say if I run a kubectl config current context, that should show me the current cluster that I am connected to, which is our cluster. So we are good, we are connected, we are authorized. However, let's see what happens if I run a first basic command of getting all the namespaces. NS stand for namespaces. That does not work. Now try and figure out why. Just think through why. Pause your video here and see. Try to think, why is this not working? We'll do the same test from Google Cloud Shell. If you're not authenticated or connected to a Cloud Shell, then just go and activate your Google Cloud Shell from here. And now once you are in Cloud Shell, then we'll try and do the same thing from here. But let's first run our gcloud container clusters list and see if we are very well at least connected to our Google console. Yes, we are. I don't like this format of output, so we'll just change this quick setting. Say I'll run this /4 this command again, and now if I run the same container clusters list, I get the output in single line. All right, so we have the cluster here. Now what if I try and run, say, kubectl config current context? Yeah, it's not set yet because we haven't done the get credentials command here. So let's do that here now. We haven't connected to the cluster from Google Cloud Shell yet. So let's do that. Container clusters get credentials. Now we are connected and authenticated against our cluster. Ideally, we should be able to run our kubectl commands now. So kubectl config current context, something like that. So kubectl is running, and remember, this is Google Cloud Shell, so some of these tools like gcloud kubectl are pre-installed, pre-configured, so you don't need to really install again. So you can see that we are connected. Now if you run kubectl get ns, let's see what happens. Well, this does not work here as well. So we saw that kubectl commands against the cluster are not working, not from our laptop, not from the Google Cloud Shell as well. Now, if you were able to think about the reason for this, that is good. That tells me that you are following along. But if not, then understand that, say, the reason for this is, remember when we created our cluster, and I'll point to a specific property of the cluster. Remember, we provided 172.16.0.0/28 as the control plane address range. Well, that's the only VM. If there is a machine within the network, and keep in mind this is a private IP address, so we need to have a VM that has an IP address, internal IP address that falls within this range, and that's the VM that will be able to access the cluster, not your laptop from outside. And this is one of the security best practices that is put in place to provide a control plane machine out there that connects that you are able to connect to the cluster from. Let's understand Google networking a little bit. To understand why we are not able to connect to the cluster. So if I pull up all the networks, currently know that there is a default network that comes built in with every project you create. Right? That's not a standard practice. We don't use default network never in production. We create our own networks with the specified and controlled IP ranges that we want to in production in real life. But by default, there is a network always that comes created with the project. Now within the network, there are subnets. And if I do a gcloud compute networks subnets list, say list. If I do that list, that gives me, these are all the subnets. And they are named default as well. So don't get confused with this default versus these default names that you are seeing. These are the subnets, and this is the network. So within the default network, like you're saying that network name as default here, you have one subnet corresponding to each region. And you will notice that each of these CIDR ranges, they are not overlapping. Like this is 10.128/20, this is 10.132/20, and so on and so forth. We have been using, for all of our purposes so far, we have been using the US East 1 region, which means all of our IP addresses are typically falling under 10.142. And a quick validation to that would be if I pull compute instances that we have, compute instances list. These are the machines we have, like we have our Grafana server, VM Debian machine that we have been playing with. All of these internal IPs, see that they are 10.142, and that's because we have been creating all of our machines, or everything that we are doing is in US East 1, and that has this address. So now that said, the problem we have is our machine, of course, my laptop is nowhere in this range, right? It's not in the GCP local or private network. So there is no way that you will be able to access your Kubernetes cluster that has the control plane address range specified as 172.16.0.0/28. My laptop won't be able to. Any machine outside of GCP network won't be able to. Even from within network, even if I SSH into my, say, VM Debian machine and try to log into the cluster, it won't, because this range is not within that authorized control range. And that's precisely the reason why we are not able to have connect from here as well, because see, the internal IP of our Google Cloud machine, Google Cloud Shell machine, even that is outside of this network, right? So you won't be able to. So now what do we want to do? What do we need to do? We will need to have a VM that is in this range, and from that VM we'll be able to authorize to our cluster. Navigate to this create an instance list. Now, what we want to accomplish is we want to have a machine that is in that control plane range. Now, how do we go about doing that? If you scroll down on the inputs that get into creating a machine, you select a region here. That's important. We are doing everything in US East 1. We want to be there. So select that. Now, if I scroll down, there's nothing here that lets us provide the IP, that internal IP that we want to assign to the VM that gets created. What controls that is this network interface. Now, default is the only VPC network. That's what we select here. Now, subnets, that's the only subnet that is showing up here because that's the US East 1 subnet, the 10.142, right? And if you take a quick peek of at all of our machines so far, all of those are in 10.142 because that's the network that we have been using. So what does this tell us? This tells us that we will need a subnet in the default network with the control plane IP range, the 192.168.0.0/28 range, and we will then use that subnet in here in our instance creation. That's how we'll be able to get a VM that is running in that range, that has an IP assigned from that range. Now, navigate to the network services network page, the VPC network page in here. What we are trying to do is create a subnetwork. So if you go to the VPC network, you see all these subnets here, and the subnet that we have been using is this one. We want to add a subnet here. We want to call this, say, SNet control plane. We want to add some description here, subnet for control plane. And we want to select the region, and the region has to be US East 1. We'll keep all of this complexity outside, and the range that we will provide is going to be our control plane range, 192.168.0.0/28. And let's leave everything, private Google access. Let's turn this on because we don't want to restrict any access from within that network. Flow logs, if we turn this on, that will generate a lot of logs. We don't want to do that. This is a free tier account, and that will impact the costs there. So let's not do that. So let's go ahead and add now. Navigate to the create subnet page real quick here. Select US East 1 as if you're trying to create a VM instance. Now scroll down to the advanced option. Scroll down to networking and look for the network interface here. If you try and look at this network interface in the default network, now you see your SNet control plane that you just created with the right IP address range. That's what we'll use now. You can very well go ahead and create the instance from here, but hey, we are SREs. We'll go ahead and use our bash scripts to create this SRE terminal Bastion Host VM. Let's take a quick look at our create SRE terminal bash script. So this is the bash script on extreme left in the first column. The second column has the startup script that it will run, and the third column is of course the config file where we are defining our variables that will get used in the bash script. So for example, the project, region, zone, etc. Important things to point out here would be the startup script that we have called out, and the name of the VM is SRE terminal, and the image we'll be using is the Debian image. Also note the network interface update. We have called out the subnet SNet control plane updated in network interface. And the startup script, let's look at that one really closely. Basically, we'll see all of these comments in our journal CTL, right? So it's installing wget utility, git, kubectl, and whatever dependencies are needed for these tools to work, and then a couple of HashiCorp tools like Terraform, Packer, then run an apt update, etc., install Docker. So all the tools get installed. Then what I've also provided is there are a few public repositories that I have that have certain tools, etc. We'll get those cloned in our SRE terminal as well. And there are a couple of manual steps that we'll need to do once the repositories are cloned. like the alias setup. We'll do that as we go along. But first, let's go ahead and submit our bash script that will create the web server, create the Bastion host SRE terminal. Let this get created, and then we will SSH into it and look at the journal.ctl output. All right, so we are good. This is created. If I do a compute instances list, you will see that the instance is up, and the private IP is 192.168 from that subnet, and there is no external IP. That's what we wanted. Now let's SSH into it. All right, let's SSH and we will review the journal.ctl. All right, so we are in. Now let's do a journal.ctl -f. We'll follow through as we see the output. I think it's important to look at the output. We are at like Terraform. I think I saw Terraform or whatever that tool was, but yeah, Docker, and now it's into cloning the repos. So I think everything completed fine. Let's do a quick validation with the tag startup script. That'll give us everything that happened. So install wget, successful, git kubectl. This is the auth plugin, and then we need the Terraform, Packer, Docker, and then this is talking about clone the public repos. There are 3 public repos, and we'll see all of these utilities, and then there are some Terraform modules, and there is this GCE bootcamp, my Udemy course related repo. And these are the couple of steps that we will need to do. We'll follow those now. So basically this is saying run cat home. Basically, okay, before I run that command, take a look at this. There is a folder called, there's a directory called repos in there. If you look at that, there is these are the 3 repositories that are cloned right here. So if you do ls, let's do this GCE bootcamp, you will see all the repositories, everything that was called out in the GCE bootcamp Udemy course. In utilities, there are a few bash scripts and aliases that you will be able to use. Currently on this machine, this SRE terminal VM that we brought up, if I look at all the aliases, there is nothing right now, and that's what we will do to see what aliases are available. So we'll just modify our bash profile file to copy all the aliases from the public repo that we cloned into the bash rc. Now if I do a source.bash rc, that will take in effect. Now if you run the alias command, there you go, you have all the kubectl, Terraform, gcloud related aliases set up. If I do an alias grep gcloud, this is just telling you that these are the alias gcloud related aliases set up. Right? So quick setups. Your machine is ready. You can use this machine to do really, work well with your GCP console, or if you're comfortable with your own laptop, by all means do that. All right. So now, we'll start using some of our aliases and connect to the cluster. So if I do a GCIL, that is the alias for gcloud compute instances list. So it gives you all the compute instances. Similarly, there is a GCCLL. That's a gcloud compute container clusters list, right? So that gives you your container. Now we'll need to connect to this cluster. We'll need to authorize. So gcloud container clusters get credentials SRE region US East 1 connected. Now there are some aliases that I would want to point out to. I'll do a grep grep context. So there are some kubectl aliases relating to context. So if I do a kccc kubectl config current context, that gives you what cluster are you connected to. So we are currently connected to this cluster. Now we should be able to run our kubectl commands against the cluster. This command kubectl get namespace is to get all the namespaces within cluster. These are all the namespaces in our auto cluster that we just created. Now keep in mind that this is an auto cluster, so all the Prometheus related, Istio service mesh related, because we enabled Anthos service mesh already, so everything is pre-set up for you that we will be able to leverage. If you look at your aliases and do a grep on namespace, you will see that there are a lot of aliases built in. Reason I'm pointing out these aliases is because I will be using these aliases in my sessions as we go forward. For example, KGNS is the alias for kubectl get namespace, and so on and so forth. So good, we are able to set our SRE terminal up, and we are connected to the cluster. If for some reason your SRE terminal Bastion host is unable to connect to the auto cluster, like if you run the kubectl get ns and it does not give you any, it does not go any forward, or it does not connect, it does not run successfully, then what you can do is just add, edit this to add this range, like 0.0.0.0/0. Basically, this is a slider notation to represent entire internet. All the IP addresses are covered in this range. So if you add this, then you will be able to connect to the cluster from anywhere. So just in case if you run into an issue, do this as a workaround. Not a best practice, because you're opening up the entire world to connect to your cluster. Of course, they will need the GCP authorization to log into your GCP console, but if anybody has that, then they will be able to connect to the cluster from their CLI. Well, that brings us to the end of this session on creating a GKE autopilot cluster and connecting to it from your machine and from a VM running in the same network. Hope you had a nice time. If you like the content, please do subscribe to the channel and hit the bell icon for getting a notification on when new videos are posted. I'm sure you had a good time, and I'll see you in the next session.